starting with the definition here of an inscribed angle. Basically, concept that you need to know is about an inscribed angle is that the vertex is on the circle, okay? The vertex is on the circle, okay? And like I just talked about in terms of our review, okay, comparatively, okay, a central angle, remember that a central angle, the angle is at the center of the circle, okay? So we already learned the difference between those two, all right? All right, so big concept for the inscribed angle, okay? In the central angle, we just talked about how the central angle is equal to the arc. The inscribed angle is half the arc. Okay, so the inscribed angle is half what they call the intercepted arc. The intercepted arc is the arc that is opposite the angle, okay, the part that is on the circle. Okay, so understand that idea. So a couple of things that could occur here is, number one, I could give you the arc measure and you have to find the angle. I could give you the angle and you have to find the arc measure. So I could make it go different directions. I could also give you the measure of the central angle and have you find the other pieces. Okay? Questions so far? All you got to understand is the inscribed angle is half the arc. All right, so in example number 1, okay? It's asking for arc measure MQR, the blue. What is the measure of MQR? Oh, sorry, TQR. Sorry, TQR. TQR. What you're supposed to do is look at this. What's the measure of angle S? 90. So if this angle is 90, what's the measure of the arc? 180, because you double it to get the arc. You cut the arc in half in order to get the angle. All right, so it's not asking for it, but if I were to ask, what's the measure of arc TSR? What if I had you go the other direction? It'd be the same. Why? Okay, creates a semicircle, or what's the sum of the two arcs together? 360. So you could just do 360 minus the 180 and get the other one. Okay? All right, so see if you can answer the following questions on this one. All right, so Charlie, what'd you get for GTA, as in the central angle? 75. Why 75?
Oh, no, 100.
So GTA is 100?
Yeah.
Okay, and the reason is, remember that the central angle is equal to the arc. So what'd you get for GNA?
50.
So why'd you say 75 earlier?
Because I was just thinking 50, 75, 100.
Oh, no. So understand these two are the same, and then this one is half. Okay? Everybody okay with what he did there?
Yeah.
All right, good. Okay? All right, so another one. See if you can find arc measure BC, and then find arc measure AB. All right, so Angel, what'd you get for arc BC?
40.
Okay, and he got that from doubling the 20. Now, it did not ask for this measure, but can anybody tell me the measure of angle BPC? What's the measure of angle BPC? 40. Okay, it does ask for the arc AB. What's AB? What is it? 140? Okay, so now, if I ask for the measure of angle BPA, what would you say? 140. All right, so a couple of things that I just want to put in perspective is, since AC is a diameter here, is 140 and 40 adding up to 180. Do these two angles form 180 degrees? And then do the two arcs add up to 180 degrees? They sure do. Okay, so kind of keep that idea in mind. All right? All right, so something else to just expand on here. Okay, can anybody tell me what the measure of angle B is? Does anybody know what it is without doing any math at all?
20.
Why is it 20? Because of what? What type of triangle is it? It's isosceles because tick, tick, since the radii are equal to each other, two sides of that triangle are equal to each other, so the base angles are equal. All right? So just kind of just continuing on with previous information. Just keep it going. All right, next page. All right, only difference here is that we're just going to add the idea of algebra. So, ideas. There are two ways to solve this one. Chris.
Okay, 5x equals 9x plus 21. Like, split like you have to multiply that by 2.
Divide by 2.
Divide, oh,
Well, which one are you going to multiply by 2? Which one are you going to divide by 2?
5x. You're going to multiply by 2.
Okay. So there's one way to do it, and that is, remember that the arc is double the angle. Okay, so if you think back, like, if this is 40, we said this is 80, right? Okay, I'm not saying that the angles are 40 and 80. I'm just throwing out an example. Okay, so how do we go from 40 to 80? Okay, we double the angle, and that's equal to the arc. Or, what Mary was going to say was 5x is equal to 9x plus 21, or maybe Chris was trying to get to this, divided by 2. Either one, okay? But you tell me, which one's easier? Which one looks easier? The one on the left, all right? Because that way you get to avoid a fraction, all right? So you just multiply by 2, you get 10x is equal to 9x plus 21. Subtract the 9x, what does x equal? X equals 21. If we plug it back in, 5 times 21 is 105. 9 times 21 is what? 189 plus 21 is what? 210? So did it work?
Yeah.
Is 105 half of 210? 210 double 105. Yes, it worked. Okay? So concept there is just understand the relationship. If you can't remember, use what I did and just randomly throw in a number. All right, if this was 40, I would double. And now you know, oh, double the angle. Okay? That's a good way to just kind of remind yourself on what to do. Okay? All right, so from this idea of the inscribed angle being half the arc, all we're going to do is talk about a couple of properties with it. Okay? And what we're saying here on this one with all the colors is that if two inscribed angles intercept the same arc, then the angles are blank. Well, here's what I'm getting at. If this arc here is, I'll choose an easy one, say 100 degrees, what's the measure of angle of the brown angle? 50. Because remember that the inscribed angle is half the arc. What's the measure of the purple? 50. What's the measure of the green? What's the measure of the tan or orange? All right, what's true about all four of those angles? They're all equal to each other. Why are they all equal to each other? Well, the reason they're all equal to each other is because they are all opposite the same arc. They all share the same intercepted arc. So the theorem basically says if two inscribed angles intersect the same arc, then the angles are equal or congruent. Okay? And you see a concrete example there. All right, so here's what's going to eventually happen. Okay? You're going to see a question like the following. Okay, I'm going to make like, it's going to kind of look like a Z, and then it's going to, let's see, let's go, or maybe an hourglass figure. And let's go A, B, C, D. Okay? And it's going to ask for two congruent angles. Can anybody give me two angles that are congruent to each other? Can anybody give me two angles that are congruent to each other? Angel.
Angle B and angle D.
He says that angle B is congruent to angle D. Why?
Because they both share the same arc.
All right, so he says that angle B and angle D are congruent to each other because notice that they are both opposite arc AC. As in, if AC was, say, 80, then angle B would be 40 and angle D would be 40. Do you agree with his assessment? Notice that the ends of their angles, okay, end in both cases at A and C. Okay? So, can anybody give me another set of angles that are congruent to each other? Yep. A and B? How about angle A is congruent to angle C? And the reason is because this angle and this angle are opposite arc BD. So for the exact same reason. Okay? So keep that idea in mind. All right? Now, that arc could be something different, like 120. So these angles might be a different number. They might be the same number. It all just depends on the angles or the arcs. Okay? Questions with that? So you kind of got to be able to see it both directions. All right. Circumscribed versus inscribed. Okay? Circumscribed, reminder, is that when your figure goes around something. Inscribed is when it's on the inside. So what we're talking about is an inscribed quadrilateral here. Okay? Notice that the quadrilateral is on the inside. The circle is circumscribed, as in it is going around the quadrilateral. All right, big concept here. There are two of them. Number one is that you should understand that opposite angles are supplementary. Okay, so what that means is that angle B plus angle R equal 180 degrees, angle I and angle D equal 180 degrees. Okay, here is why. What's the sum of all the angles in a circle, or the arcs in a circle? 360. Do you see how angle I here is opposite arc BDR? Angle D is, this angle is opposite arc BIR. The sum of those two arcs is 360 degrees. What's their angles? Their angles are half. What's half of 360 degrees? 180. Okay? So that's what you have to understand. Okay? So the opposite angles are supplementary. And then just a number, this is more just a reminder, and this is from the last chapter, is remember that the sum of your angles is 360 degrees from a quadrilateral. Okay? That's more just a reminder. Okay? So, for example, if I were to throw out that angle R down here is 100, and angle D down here is, say, 70, you should be able to tell me what angle I is, and you should be able to tell me what angle B is. What's I? What is it? I is not 70, because then you're saying that opposite angles are congruent to each other. We said opposite angles are supplementary. What's I? 110. Okay, 180 minus 70 gives me 110. What's B? 80. Okay, And all four of those angles are gonna add up to 360 degrees, okay? Now, from there, you should also be able to give me different arc measures as well, okay? If we were to throw that out there. All right, two more theorems. If an angle is inscribed in a semicircle, what they're talking about is this angle A. Notice that the endpoints of A are on the endpoints of a diameter, okay? So, if an angle is inscribed in a semicircle, then it is always going to be 90 degrees. It's going to be a right angle. If an inscribed angle is 90 degrees, then it intercepts a semicircle. It's just kind of going the other direction. Okay? So notice that it's basically, think about this. If this is 90, then the arc opposite is 180, which makes it half of a circle, and therefore that line is a diameter. Number two, a quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. Okay, so that's kind of like what we just talked about there. So, using number two, are there any examples that you can think of from the last chapter of a figure that cannot be inscribed in a circle? So, for example, can a square be inscribed in a circle? Yes? So you're saying, if you're saying yes, then the opposite angles in a square are supplementary. Yes, you are correct. Okay? Because wouldn't you agree that a square has 90 plus 90 is 180? And going the other way, 90 plus 90 is also 180. Can a rectangle be inscribed in a circle? Can a parallelogram be inscribed in a circle? No? Maybe. When is that maybe, or when is that sometimes?
When it's a square.
When it's a square or a rectangle. Because remember, in a parallelogram, you might have a situation where it's like 100, 100, 80, and 80. The opposite angles are equal to each other. Are they necessarily supplementary? No. Okay? So think about that. Not all quadrilaterals are going to be inscribed in a circle. Okay? Only some of them, and it's based upon their properties. Okay? All right. Last page. Okay? You are supposed to use the concept that we just talked about to find the measure of all four angles. See what you can do. Any ideas on equations here? Because, for example, I'm seeing 3x plus 5x is equal to 180, and that's wrong. Because then you're saying that t and 80 are supplementary, and therefore you're saying that this line and this line are parallel, but they're not. Okay? So, anybody have ideas on how to solve? Andrew? You can, but then you only have one equation. You're on the right track. What's 2y plus 5x add up to be based upon what we just talked about, 180? What does 3y plus 3x add up to be? 180. We just got done saying that opposite angles in an inscribed quadrilateral are supplementary. What concept do we now have to use in order to solve? Substitution or elimination.
I really want you to have on my head.
What method do you want to use?
Substitution. I think. No, actually. Yeah. Elimination, because you can do the three.
I like elimination, but that's me.
Well, I like substitution.
Okay, so go with substitution.
I just thought that you could.
You either gotta get one of the letters all by themselves so that you can substitute in the other equation, or you gotta get opposite x's, opposite y's by multiplying. Which method do you wanna try and do? Multiplying. Alright, so I need either opposite y's or opposite x's. Which one do you wanna go? Y's. Alright, so what number do 2 and 3 both go into? Alright, so I need one of them to be a 6, one of them to be a negative 6. So what do you want to multiply the top equation by? 3. That'll give us a 6y, a 15x, and 3 times 180 is what, 540? Okay? Alright, so that means the bottom equation we're going to multiply by negative 2 to get a negative 6y, so negative 6y, negative 6x, and negative 360. Okay? When we go to add these two equations together, the y's cancel out. That's why it's called elimination. And we get 9x is equal to, I believe, 180. What does x equal? Divide by 9, divide by 9. X is equal to 20. Okay? So, what's 5 times 20? 100. So what does 2y have to now equal? 80. What does y equal? What's 80 divided by 2? 40. So y is going to equal 40. Let's test it out with the greens. 3 times 40 would give us angle S is 120. And then 3 times 20 would give us 60. Does it work out that the opposite angles add up to 180?
Oh, yes.
120 plus 60 and 100 plus 80. It works out. Okay? All right, since we struggled with that one, let's do one more. Let's do this one where you got to find x and y. This one's a little easier. Use the concept of opposite angles being supplementary. If you're not sure on how to get the 14, okay, 5x plus 110 equals 180. Subtract the 110. 5x equals 70. X is equal to 14. Okay, for the y, these two angles are supplementary, so 104 plus 2y equals 180. Subtract the 104. 2y is equal to 76, divide by 2, and y is equal to 38. Okay? So understand inscribed quadrilaterals. Opposite angles add up to be 180. Big idea. Okay?